Hello everyone. Welcome back to my YouTube channel Execute Physics. Today we are going to deal with questions from Work, Energy and Power from 2023 question papers. First question is from multiple choice paper 2. So the equation used to find the change in gravitational potential energy of an object can be written as shown here. The change delta EP is equal to y times z times delta h, where delta EP is the change in the gravitational energy and delta h is the change in height. Which row gives the quantities y and z? So we know that the gravitational potential energy is given by the relation. What does the gravitational potential energy give you? What is the relation? It is mass multiplied by the acceleration due to gravity, g represented by g, multiplied by the height of the change in height, or the height at which the object is placed. So the gravitational potential, we know that delta h is the height, and so y and z would be the mass and the acceleration due to gravity or the gravitational field strength. So the correct answer is option A. Next question. A machine has a power input of 200 watt and a useful output energy of 1 kilojoules in 6 minutes. What is the efficiency of the machine? So you have a machine which takes in a particular amount of power, which is around 200 watt, and that machine delivers an output power. Okay, so you are asked to find out the efficiency, but the given values over here is output energy. So our first job is to find out what is the output power delivered. So we know that power is the rate at which the energy is delivered. So output power is equal to energy divided by time. The energy is given to be 1 kilojoules. So 1 multiplied by 1000 kilo, right? So it's 10 to the power 3. So kilojoules divided by 6 in 6 minutes. The rate is 6 minutes. So 6 times 60 to convert that minutes into seconds. So that will give you 2.77 watt. So from the 200 watt of input, the output delivered is just 2.77. So it's very less efficient machine. Am I right? Yes. So let's find out the efficiency. So efficiency is output power by input power multiplied by 100. We need the efficiency in percentage. So output power is 2.77 multiplied by the input power is 200 volt multiplied by 1000. So the value would be approximately 1.38, which is equal to approximately equal to 1.4. So the correct answer is option C. Option C is the correct answer. 1.4 percentage. Very less efficient. Not at all efficient. The machine is. So the next question. What is the unit of power? Simple question, right? Direct question. It is watt. Joule is the unit of energy. Okay, don't confuse between both. Joule is the unit of energy. Watt is the unit of power. So the correct answer is option D. What is the unit of power? Next question. State the principle of conservation of energy. So what is the principle of conservation of energy? What does it say? Energy can neither be created nor destroyed. It can only be transferred from one form to the other. These two statements have to be clearly written to get both the 2 marks. It's a 2-mark question. Okay, so this is the answer. Next question. It's a paper 4, so it has got a lot of subdivisions. So B part of the question says a wind turbine has a maximum output power of 1.8 megawatt. Mega is 10 to the power 6. So, and the turbine operates at a maximum power for 4 hours. Define kilowatt hour. See, kilowatt hour, usually children make a mistake in this. Seeing this unit of watt, they simply write it as a unit of power, but it is wrong. Kilowatt hour is a unit of energy. How do you define it? It is the energy delivered by 1 kilowatt of power in 1 hour. So it is a unit of energy. Don't forget that kilowatt hour is a unit of energy. It is the energy that is delivered by 1 kilowatt of power in 1 hour. That is a definition for kilowatt hour. So you have a turbine whose output is given to be 1.8 megawatt and it operates for a time period of 4 hours. So let's find the next part of the question. Calculate the energy produced by the wind turbine operating at maximum power for 4 hours. Give your answer in kilowatt hour. So how do you get the energy from power? Energy is power times the time taken. So power is already given to you as 1.8 megawatt. Mega is 10 to the power 6, so 1.8 into 10 to the power 6 multiplied by, for how long is it operating? For 4 hours. So what would be the energy that is delivered? For 7.2 into 10 to the power 6 joules. So to convert that into kilowatt hour, what should we do? We know that 1 kilowatt is 1000 joules. So you have to divide this divided by 1000 to get the answer in kilowatt hour. So the answer is 7200 kilowatt hour. Next question. The radiation from the sun is the main source of energy for most of our energy resources. State two energy resources that are not due to radiation from the sun. So we have different energy sources, right? So you just have to state two of them which is not from the sun. So any two, like the nuclear power, nuclear energy, then the tidal energy, any two. There are even more. Any two you can write. Okay. So next question is, it's again a paper 2 question. The diagram shows the energy stores for a mobile or a cell phone and how the energy is transferred between stores. What describes how the chemical energy is transferred? So where is this chemical energy? This chemical energy is within the battery. So chemical energy is transferred to internal energy and kinetic energy, creating heat and sound. So where is it stored? And how is energy transferred? It is transferred from electrical energy to, it is transferred from chemical energy to the electrical work done to deliver the required internal energy and kinetic energy. So the correct answer is option A. Last question. A wind turbine is 30% efficient and has an output of 2.5 megawatt of electrical power. What is the power input to the turbine? So it is mentioned that the efficiency is just 30% and it has an output of 2.5 megawatt of electrical power. So what is the input? It is just efficiency is output power by input power multiplied by 100. So just have to substitute into the relation to get the answer. So the solution is shown over here. You just have to find out the input power. The answer is 8.3 into 10 to the power 6. That is 8.3 megawatt. The correct answer is option B. I hope it's clear to you. So that's all for today's video. Hope you have understood. Please make sure to like, share and subscribe. Thank you.